Hi, everybody. Oops. Hi, everybody. This is Mr. Folly. Oops. And welcome to, let me get rid of this, 5.1, where we are going to learn how to balance some equations. Yeah. So balancing equations, you did this in middle school. You might have forgotten it. You might not. Balancing equations is done to show that matter is neither created nor destroyed. This shows the law of conservation of mass. So if you look at this, some of the H's and Cl's disappeared. So do you see how I have 1, 2, 3, 4, 5, 6 H's, and I only have 1, 2, 3 over here? That can't happen. Okay, so the world does work where if I have 1, 2 H's on the left, I'll have 1, 2 H's on the right, and 1, 2 chlorines on the left, 1, 2 chlorines on the right. Okay, so this would be a balanced equation. All right, so notice I would need 1 H2, 1 Cl2 to make 2 HCl's. I should have made these like separate, but that's all right. All right, so let's do some examples. I'll show you some that are tricky. So if this gets tough, what we like to do is make a column to count. Column to count. Okay, I've heard people call it an atom inventory. See how there's carbons? So there's 1 carbon on the left, hydrogens. There's 4 hydrogens on the left, and oxygens, there's 2 oxygens on the left. And then on the right-hand side, I'm going to keep track of how many I have here. I have 1 carbon on the left. I have 2 hydrogens on the left, and I have 2 plus 1, 3 oxygens. I keep saying left. This obviously is the right-hand side. So those are on the right. So when I look at this, oops, I put right-hand side is what I was looking for. So notice right away my hydrogens don't balance. So I need to put something in front of this to get me 4 hydrogens, okay? I cannot change that. H4O is not water, H2O is water. So I'm going to have to make 2 waters. When I do that, my hydrogens change to 4, which was the goal. But now I have 2 oxygens plus 2 oxygens, which is 4 oxygens, okay? So now my oxygens are messed up. Oh, no. So I need to make this 2 turn into a 4. Again, I cannot change this. I have to put a number in front of it. So 2 times 2 would be 4. So now I check, and I see I've got 1. Whoa, great job changing the thing. You probably even saw me there at home. 1, 1, 4, 4, 4, 4. We're balanced. That's it. Okay. Now you do not always need to use that column to count method, but if you're stuck, it works. Okay. So, oh man, this is already in. Let's pretend this isn't here. Hey, you know what? Let's use that wonderful black marker. Oops, wrong one. Wonderful black highlighter. Oh, come on, you can do it now. And that way we can write in oh so fun colors. And then we'll do this in orange. Okay. So right now, if you didn't want to use the column method, you can just kind of count how many NAs are on the left, how many NAs are on the right. That's good. How many N's are on the left? 1. How many N's are on the right? 1. That's good. How many O's are on the left? 3. But over here I have 4. Oh no, I have 4. And because I have 2 in the same spot, I'm going to jump right to that column method. Na equals N equals O equals. Na equals N equals O equals. So Na, I have 1 and 1, and I did that before. Oxygen, I have 3, just these 3, and then 2 plus 2 is 4. Now, I'm trying to think of a number that I can get these to be equal to each other. Having them in 2 different spots is confusing and hard. So if I'm ever stuck, we get to come to our suggestion of double the big guy. Instead of double, we'll say increase the big guy. By 1. So right now this is a 1, so I'm going to make it a 2. If I make it a 2, 2 sodiums, it distributes 2 nitrogens and 6 oxygens, okay? So now I'm going to just start at the top. I want to get my NAs to be 2. I'll throw a 2 right there. Gives me 2 NAs, gives me 2 N's, and then 2 times 2 is 4, plus 2 is 6. Oh, hey, look, it worked, okay? Yay. Let's do some more. All right, now we can do some of these that we can just call by inspection. So you can always use the column method, but you just kind of count them out. I've got 2, I've got 2. I've got 2, I've got 1. So I got to make this a 2. That changes me to have 4 hydrogens now. So put a 2 right here. And then I check it. 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. Hey, I got it right. Same thing here. 2 nitrogens, 1 nitrogen. Let's fix that right now. Boom, boom, boom. 2 times 1 gives me 2. Now I have 2 hydrogens. Oh, no, I have 6 hydrogens. To get 6, 3 times 2 is 6. So let's check it. 2 nitrogens, 2 nitrogens. 6 hydrogens, 6 hydrogens. Yay! Now, whenever I see a big dude like this, I always do it by, whenever I see, this is called a combustion reaction. Whenever I see oxygens in 2 spots, I do my column method. I admit, I quit before I try. 4 carbons, 10 oxygens. I'm sorry, 10 hydrogens, 2 oxygens. Over here, 1 carbon, 3 oxygens. I don't know, I did it out of order. And then 2 hydrogens. So, first thought, carbons. Yay. Gives me 4 carbons. 8 plus 1 is 9. 10 hydrogens. Dun, 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 dun. 10 hydrogens. That's good. And then I have 8 plus 5 is 13. Oh, that's not 13. This was 10. Whoops. And then this was 13 oxygens. Well, shoot, there's not a number I can put in there to get 13. So remember what we do when we're stuck? Move the big guy up by 1. 2. 2 times 4 is 8. 2 times 10 is 20. How do I get 8 here? Yeah, I put an 8 here, right? And that gives me 16 plus 5 is 21. Ooh, is this getting long? And then to get 20 hydrogens, I need to replace this 5, and I put a 10. That gives me 20. Whoops, make that look like a 10 instead of 16. So 16 plus 10 is 26. My good, hey, I know a number that'll go right there. And that'll be 26. And that'll be the end of it, to which I'll say, 2.